another important Hello. Yeah, this evening we have an important CPD, which is Geospatial Application in Transportation Infrastructure. Talking about transportation, we believe, and I believe that without transportation infrastructure, our economy is not going to develop as much as we want. And today, we want to underline the fact that geospatial applications play a very big contribution in developing our nation, typically our infrastructure, road infrastructure. So we have in our midst a PhD scholar, and he's at the Regional Transport Research and Education Center in Kumasi, in KNUST. He holds a bachelor's degree and an MPhil in geomatic engineering degree from Kwame Nkrumah University. His appointment as a lecturer with the civil engineering at Kumasi Technical University underscores his deep understanding of geospatial technologies in the academic and the industry. He's a co-founder of a startup, GeoBot Africa Consult, as a journalist and a specialist to drive innovation in geospatial solutions in real-world problems. As a young researcher, he has interest in applying spatial data science, that's GeoAI, in transportation and health-related issues. He exhibits professionalism and strong motivation as a team player. In recent times, he has authored and co-authored peer-reviewed journal papers and is part of the recent Volvo Team Award granted for essential GIS training. Please help me to welcome the scholar, Tara Entry, to take us through this presentation.
Thank you for the introduction. Greetings to all of you, and thank you for this opportunity.
Greetings to you too.
So I'd like to share my screen. It's okay.
Okay. Yes, okay. Please go ahead and share your screen.
So right after taking you through, I would also like to demonstrate a little bit of these applications that are out there. But I don't know if time will favor us for me to show more. There are enormous applications that are open for everybody to use in terms of geospatial applications in transport infrastructure. So I'll start by saying that in our modern society, we heavily depend on infrastructures. And geospatial applications in these infrastructures simply means that the measured data on our transport infrastructures are coming with geographical location data that will enable the transport professionals to plan, monitor, and improve transport infrastructures. The benefit comes in several layers. So I will double down on the second and third layer, which is safety, efficiency, and sustainability. Deep down in the third layer, we dive into route planning and optimization. We also want to look at the condition of the infrastructure. And for ground transport, you also want to look at traffic management and monitoring. parking management, etc., etc. So these are some of the benefits if you're incorporating geospatial application in transport infrastructures.
Hello, Dr. Terra.
Hello.
Please, is it possible you put on your camera?
Right. Okay. Okay. Can I be seen? Because I can see myself.
Yes.
Okay. Thank you. Okay. So, in order to answer questions answer all the questions related to transport infrastructures, you want to also look at other infrastructures because transport is interdependent on other infrastructures. And so for the little data that you see in front of your screen, you have road linked to energy. And so on the road, we supply gas or fuel. And we have road linking to water, you supply water. Road link to communication means on that road you maybe move with materials to maybe a landline area, or you want to inspect your connections. And then the main transport may be having access to places, workplaces, and home. And this is crucial when you are designing any application because when it comes to infrastructure, there are what we call the cascading failures. Because if any of the infrastructure fails, it can have influence on what you're looking at. And so it's important that you start from here, knowing that depending on the context that you're looking at. Right, so considering this, a concept was birthed, which is called a smart city. So you want to properly allocate better resources for all your infrastructures. And your city services and operations are optimized inside the smart city with sensors, system engineering, artificial intelligence, and information and communication technology. Similarly, another concept was also birthed, which we call intelligent transport system. Similar approach, but different objective that looks at improving safety, mobility, efficiency, and sustainability. So here is where we are going to center our learning. So here in ITS, which is Intelligent Transport System, the major part of it, or the main component is data. And the data is coupled with sophisticated models to process, analyze, and then store your data. In order to acquire your data, there are different ways of sensing or collecting these data. We can easily categorize them in three. We have the infrastructure-based sensing, the vehicle onboard sensor for vehicles, and then we have the aerial sensing. But in this subject, we will focus on infrastructure-based sensing and aerial sensing because they connect together to form the infrastructure, geospatial application infrastructure. For vehicle onboard sensing is quite different. Under infrastructure-based sensing, the infrastructure that you'll be looking at include roads, bridges, tunnels, terminals, railways. You can look at even traffic controllers and traffic signs. And you leverage sensors in any of the locations on these infrastructure. It could be intersections, a certain selected road section, so that you can improve traffic. We'll look at the condition there. The role of the sensors in infrastructure-based sensing, you can go deeper into traffic flow detection. That's where we count vehicles. We look at the speed of vehicles, density, look at trajectories, and we look at vehicle classes. You can also look at travel time estimation, looking at when you pick multi-locations or origin and destination. There is also traffic anomaly detection. So you can also look at a whole wide network, look at abnormalities. So you'd want to look at a vehicle, when a vehicle breaks down, what happens? So it's more like a what if scenarios or what if simulations. When there is a collision, when near crash, when you are going the wrong way, what happens? And there are also little instances like parking detection, free speeds, etc. Then we come to the area-based sensing. So the area-based sensing here leverages drones and photos from space. So when I say photos from space, satellites, to look at road user interactions and look at also traffic theory-based parameters. So in my case, my PhD research was based on using satellites to look at aging road surfaces. So I was able to tell the road characteristics, the road profile that I'm dealing with. I was able to tell which part of the road has defects like potholes, depression, rutting, and I was able to tell uncertainties when it comes to in the future sections of the road that will be critical for inspection. And so here, when it comes to other benefits, you can also look at flying accident reports. So you can, when there is an accident on the infrastructure, you can use these area-based sensors to look at them. You can do some detection tracking. So you look at vehicle tracking. You can consider the number plates. So you take aerial shots, get the number plates, and then look if there are traffic signals communicate to each other, they can tell the time it passes from one traffic signal to the other. Then we have the lane detection, vehicle tracking, and for you to know certain traffic parameters like speed and what have you. Right, so what are the characteristics? Because we established that the geospatial applications in transport infrastructure is that the measured data comes with location reference. So how do we get, or where do we get them? Your primary sources often comes from one, your mobile embedded GPSs. So if you know this app called WAS or Waze, depends on how you want to call it. It's more like an advanced traffic information system for users, so people can on the road tell where the police stops are, what has happened on the road if there is a collision. So anybody else using WAS can tell any event that is happening on the road. And then there are also like vehicle probe GPS devices. So you can acquire like a separate GPS, drop it in your vehicle, have it connected to any other device. Then as you're moving on the road, you can have an update of where you are, your vehicle and all that. And then we have also another vehicle probe that comes with sophisticated sensors like LiDAR, GNSS, IMU. And then they pass on the stretch and capture these data for you to integrate all the data and then tell the state of the system that you are inspecting. Then we also have free sources on internet and web services. So on internet, we have open route services, we have Google data matrices that provide like travel time information, advanced traffic information for free. I would say, but Google you would have to pay, but it's cents. It's not cost. It depends. So yes, you get open route services and then Google distance metrics API giving you traffic information. And And then their formats is in markup language and JSON format. So you can integrate them into any customized application that you have that requires like route optimization. Let's say you are into delivery services and then you want to, enhance your services. You can design an application and have these APIs sitting to help you do some route optimization and what have you. Then there is a pipeline for the spatial data that you use in this transport infrastructure. When I say a pipeline, I mean it's a process that you can't avoid. And so often the first step comes as one operational evaluation. The second step is how you tend to acquire the data. Third is often the data comes multivariate to become different variables. So you'd want to normalize as they are passing in order to reduce variables that will sort of shift the whole analysis to one side or sort of overpower other variables. Then you want to do data cleaning. You want to also look at like data integration and fusion. You want to look at feature extraction, statistical modeling, the key part, which is visualization. So, operation evaluation, it's at that very point that we ask a lot of questions on safety and environmental conditions, operational environmental conditions for that infrastructure. And we would also want to know that what the approach that we are doing or using to inspect the infrastructure is economically justifiable. In acquiring the data, we call something coverage. You would want to be sure that you want to do a wide surveillance, which we call global inspection, or you want to zoom to a very specific section, which we call local inspection. Or you can do a hybrid. So in my PhD research, I did a hybrid. So you can find a way to do a wide surveillance, which is an aggregate inspection. Then you zoom into local where you disaggregate. It's also at that point that you also want to know the sensor type. So are you going for an active sensor or you're going for a passive sensor? So passive sensors will be what the physical structure will be emitting to your sensors over time period. And then active sensors is what when your sensor through light to the physical structure, their response to the light that could tell the state of the structure, depending on what you're looking at. Then you want to look at storage and transmission. Then cleaning, data cleaning, as the name goes, you're cleaning. Then we have the fusion and integration. So you have more variables and we have fusion. So we have single source data, very isolated, and they could tell you different things about your transport infrastructure. And you can find a way to assemble them and then pick out the dominant feature vectors. That would so when I say dominant feature vectors, you can have about 100 variables, but 4 of them could speak true to the feature that you are looking at. And so that is, statistically, we have data reduction techniques that you can apply to do that. And then when it comes to integration, you can also combine different sensors that speaks to different parts of the infrastructure and then merge them. When you're able to do that stage, the next stage is the feature extraction, which is taking extract certain portions of the data that will allow you to tell the state that you're looking for. The system, are you looking at vehicle count? How do you do it? Are you looking at density? How do you do that? So it depends on the state you're looking at. Then the last but one is the statistical models. So there are implementation of several algorithms at this stage. We can talk about supervised learning approach. After you've been able to extract the portion that you're interested in to train your models here, we talk about unsupervised learning approach. We have semi-supervised learning approach. So it's often the supervised learning approach is manual because after collecting your data, you want to correctly align it to a certain label before training, getting your hyperparameters very well tuned before you sort of forecast. And when it comes to unsupervised, it's more automatic. So the algorithm is able to separate based on patterns, and you work with that. The semi-supervised will be after the patterns and groupings, you can pick them and label them. And so that becomes like a hybrid of both the supervised and the unsupervised. The last part is visualization. So when it comes to visualization, there's a science and partly an art as well. And this part is crucial, but because it's not the main center of what we are supposed to do today, I'll just brush over it. But I wish anybody here hearing me should take visualization very serious, which we call cartography, if you don't mind building up your skills in cartography, because you want your maps to be able to communicate to your users. And when you're dealing with multivariates, because you have different sensors for your transport infrastructure, you would want to make sure you adapt different visualization like parallel coordinates. You want to, that is also interactive. You also want to have an interactive map or heat map, or you want to also introduce scatter matrix plots. You also want to do, let's say, a historic heat map that shows the beginning of when you had your data to maybe the present day, depending on the data you have. So that's with the visualization. And that brings me to the end of the pipeline when it comes to dealing with geographic data in transport infrastructure. Now we can talk about the quality. Majority of these data comes from open source. So we have website providing us data. We have our own GPS is giving us also data. But they all are riddled with certain errors that you have to be dealing with no matter what. So if you are getting data from a third party, like the Google Distance Metrics API, you can't give you historical data. If you're asking it in batches, then you should be open to scripting so that you can load the data very quick. Because if you are, from my center, we developed something like that. In KNUST, we had an application that could request data from Google API, and when the data comes in, nicely arrange them, and so we don't have any person having to go through the data and then put them together. That's a lot of work. The second step is most of the data also come now. Your request will come now or missing. Before you process it, you must also know how to work on missing data. A lot of statistical approach to missing data. The simplest one may be interpolation. What have you? The third part is the errors that come with the data. So we have an OSM network. So they call it OSMNX. So often we request road network data from them, and it's in such a way that the data comes with topology, like a network data that comes with topology already. But it's not always working. You would have to put it somewhere, inspect all your topologies before you can work with such road network. So it's the same thing. You have data that you're requesting that they come with errors. And there are also instances that when you are requesting for traffic data, you have to be careful because some of the data that are coming in will come from, because it's taking data from mobile phones and how they are traveling from one point to the other. It could be that the mobile phone providing that traffic data was in a long vehicle, and so was traveling slow and missed smaller vehicles. So that means the traffic data that you requested may not be a true representation of the road segments. There are also instances where some vehicles move faster than the other, and that can also give you a wrong reporting. And there are also instances where the volume of vehicles on the roads are not much, and so when you request for that traffic information, it will also not be a true representation of what you are looking for. So these are things that in terms of data quality, you'd want to pay attention to. Right, so I would like to quickly demonstrate, if there are no questions, I can quickly demonstrate some few little sources out there that you can use for your geospatial application in transport infrastructures. So I'll just minimize the slide and I'll take you to OSM Wizard. Apologies, where is this thing? Okay. Okay. So immediately OSM Wizard will take you to this window for you to search your location. So what it does is, I don't know if you all see my screen, so it takes me to a web browser. In the web browser, I have a lot of information. This is somewhere in Berlin, but I want to come to Kumasi. I am in Kumasi, now type KNUST Kumasi. Okay, file. So it takes me straight to KNUST Kumasi, in the road network. Then I call in my region of interest. So I just want a small segment to demonstrate this. Not that much. And so what this application does is it's also connected to Open Route services. So the moment I select the area, it's going to go into Open Route services to request for traffic information there. So I click on generate scenario. It will quickly download, convert all my road networks to a network graph, align them with traffic data, and then quickly I'll have a network here like that. And so I can simulate, so I don't know if you can see it clearly, some vehicles moving. Maybe I would have to pause and then make the visualization something fun. So come to vehicles. All right, so I will choose draw constant sizes, and I want it to color the vehicle by speed. Okay, then I'll run it. So there, I have traffic data of what is happening in KUST now, and there is more to this. So what you are seeing in the middle there is also traffic signals behavior. So you simulate this traffic in just a few seconds. You can put in detectors to collect the vehicle speed, you know that. And then later on, you can analyze and know what is happening on the segment. I wouldn't waste time here. So I'll quickly move to another demonstration, which is this one. So another OSMNX that I have if you can see on my screen. So you can script this in your Python, IDE, depending on which environment you are working in. So you call in network and X, OSMNX, and one that helps you. You give your location, the extent that you're looking for. You can give extent based on latitude, longitude, and the distance for it to give you a coverage like this. So that was my query. I wanted somewhere around the full probe in Kumasi. So right after the request, I have this road network presented to me. And the next thing is I would want to know the behavior of the network. I want it described. So the basic statistics is also shown here. So I know the number of edges, I know the number of nodes, the edge length. I can also plot them. I can look at edge centrality. So yeah, if there is opportunity to take you through all these, there are more that I can also show. But I'll end it here and then wait on your questions. Thank you.
Thank you very much, Doc, for your presentation, and I was really enlightened with what
Thank you.
some of us are doing out there. I'd like to recap what Doc has just taken us through before I go to the questions that we have on our page. So in the beginning, God created heaven and earth. Doc talked about okay, so the whole presentation is about transportation. It's about transport infrastructure. Yes. Right. And you introduced us that transport is an interdependent, and it links with other infrastructures such as our water, electricity, all the other utilities that you mentioned. You also talk about the smart city and intelligent transport systems. And this thrives on data, as you mentioned. The intelligent transport system sensing and its categories, you talked about that. And then you mentioned that infrastructure-based sensing, which comes in different forms. We have the parking sensors, the traffic, and a lot more that you mentioned. Then you also talked about the area-based sensing, which in your research, you use drones, you use satellite images to look at road conditions.
Right.
With the area-based sensing, you can also use drones also to sense your data. And this also looks at vehicle tracking and a lot more that you mentioned in that area. From there, we moved on to characteristics of location reference data. You talked a whole lot in that area too about the GPSs and the basic data collecting tools like our phones. Then we have several apps like the Waze or Waze that you mentioned that tells us about the traffic conditions and the road conditions at various places in the road network. They also talked about structure of the data, where we looked at how the data is being processed and the preparation of the data. Then data cleaning, fusion and integration of the data, then feature extraction, and then data modeling. One interesting thing about it is also you talked about the visualization. That is the cartographic part.
Yeah.
I quite had a feeling that you really wanted to talk more about that, but because that's not part of your presentation today, maybe
Yeah.
please invite you to come again to talk about visualization and cartography. I would love that too.
Uh,
All right. Then about the data quality. Then he took us through a demonstration on how to use the OSM tool to collect data. And I believe this is all open source. It's for free, right?
yeah, they are all free.
Okay. All right. Please, I know I'll be contacting you and would like to encourage you to give us more. This one will be proper lectures on how to use these tools.
Mm,
So we have some few questions
okay.
in the chat. Yes. So I'll read out the questions and then you try to answer them for us. Okay. So the first one is talking about what is the OSM user application?
Oh,
Yeah, he's saying that you can see it running locally. How can I don't know what word is. How can people have access to try it?
so I can send, maybe drop the website where people can access. They often it's a German-based company that has found a way to integrate OSM into their transport simulation program. They are called Sumo. So
Okay.
I can share their main website for people to learn. I think their main language is markup language, XML. So it's easy to customize. It's easy to, so the local thing you were saying means I keep customizing them to suit my preference, what I think will work for me when it comes to traffic.
Okay. So I think we've answered Francis' question, but I also have a follow-up question on that. When you
Okay.
did your demo, I saw vehicles moving. Is that live? And if it's live, what is giving live data for us?
Right. So not necessarily live. That what you are seeing is like an average traffic information. So yeah,
Okay.
it's from a live traffic data, but that is an aggregated form.
Okay.
I don't know if I didn't confuse him. What I mean is that yes, the data that the simulation is using is a real data.
Okay.
It's just that it's in an aggregate form. So what it means is it can be collected from morning and evening and lumped together to run in the model.
Oh, okay. All right.
Yeah.
Okay.
Mhm.
So it's a model, collect
Yeah.
data, and replicate it in the system. Okay. All right.
Yeah.
Okay.
So the interesting thing is the system does that data collection for you. So
Okay.
if you want to get the raw data, then it's up to you to make sure the model is close to your real world. Then you put what we call detectors on the road. Then they will record the traffic information for you. This time in numbers for you to analyze. Okay.
Okay. So your data that you are modeling, what sensor was used to collect that data?
Majority is mobile phone.
Mobile phones. Okay.
Yeah,
Okay. It's
mobile
clear
phone.
now. It's clear now.
Yeah.
So it's like when I'm walking around with my mobile phone, you are collecting data from my mobile phone.
Exactly. Exactly.
Oh, okay. That's
Same way
privacy.
if you're in the bus or you're in a vehicle.
Yeah.
So all those are logged somewhere.
Okay. All right. The next question is okay, it's about the link. So please don't forget to share the link with us. And if you have any material on how to access that or use that functionality, just put it in the WhatsApp chat group. So all those who are not in any of the chat group will be missing it. So please try and join our chat groups so that you can get access to all this information. Okay.
Right.
He says, I can see the the traffic data in the simulation, does it record it somewhere, or you have to make decisions based on the visual stimulation that we see?
Well, I think I've answered it. So what I'm saying is that the the designers behind this application have, depending on the location that you are trying to work on, they already have a way of requesting for traffic information. But if you want the raw data to work on it yourself, you just have to introduce detectors. If we have transport engineers here, they know about detectors. They put it on the road, something like pneumatic tubes, magnetic inductors, and all those things. So when vehicle passes on it, they can record traffic information. So similar to this application, the vehicle's moving. I'll just introduce a digital detector, and then it will record all the data for the vehicles moving. I'll have raw data, then I can work on it. Yeah.
Okay. 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 So, Samuel Owusu is also asking, he's saying that, please, I did not really hear that particular names of the OSM application. Please, can you mention them one
Sumo.
time?
SUMO. Sumo.
Sumo.
Yeah.
UMO. OSM Sumo.
Yeah.
Okay. All right.
Right.
And we have, how can the spatial analysis or work done in the transportation sector be translated into actions for national development? So another question from Francis.
Can you
It says,
ask that question
asking
again?
that how can the spatial analysis or the work done in the transportation sector be translated into actions for national development? He's actually talking about your work that you've done. How can we translate in Ghana to improve to help with the national development? I believe this is trying to say.
Yeah, I do think it can be done. So for instance, uh, with my research, my PhD research, it was an automated script. So all that you needed to give it was satellite data and road line work, and then all the other information will be provided. And so you can't be at the comfort of your home as a transport professional to look at what the data is telling you. Then you can make a decision to go on the field. So that is at least a starter of cutting this cost of inspecting roads. We are talking about millions of cities in
So you want
inspecting road
some of us
conditions.
from job, you want to
We
take
also
that
have
away.
we
You want
also
to take some
have
of us our job away.
oh no. It's not to replace the entire work, it's to couple with the manual work actually. It's so that you don't have to move on an entire 10 kilometers before you find a pothole. So uh that's the whole idea. It's not to take away that job. Then like what I've also illustrated, you when you have traffic information on a website, it's which is open for everyone, then people can access it, use it to make decisions in terms of businesses and what have you. So this Sumo website, looking at the raw data you are having, you do not have to spend money to go near road necessarily to collect traffic data before you can make any decision.
Okay.
So at least these are something we can start with.
Okay. So to also to add, it can improve our time in which we react to our maintenance schedules on our roads. Instead
Right.
of the issue of contract and for them to go, it takes a longer period. If you have this data, you can be in your comfort of your office, and then you inspect the road quickly, done within the shortest possible time, and then the road maintenance team can also go out to maintain the road. Okay. So we have another question. How does the traffic engine translate vehicle location to OMS linked speed estimates?
It's just from your phone. So your phone are already communicating with signals in space. So your base vectors gives you like another vector which can be translated into traffic parameters like velocity, speed, distances. And so they are quickly logged onto some online database that anybody can easily request and use it for any applications. Yeah.
Okay. So another question from Elvis says, can your model be used to collect features like billboards along roads, considering the vast number of billboards, billboards, let's say in Accra?
Not something that I've explored with. Sumo is just linked with traffic information. The
Okay.
other part, which is the road network, is also, it depends on the people who are contributing to OSM. So if anything, it will be you collecting your billboard data and then you couple it with the existing data that has been contributed on OSM, but I'm not sure we'll give you all the billboards you're looking for.
Okay. Okay, so another question is, can we have a series of class on the OSM and how to retrieve and process data on it? If it is even a paid class, this was too short.
Uh,
Yeah,
Not my fault too.
yeah. So I think that we would have to come up with a tutorial class where you take us through how we can use this OSM.
Right,
Yeah, okay.
right.
So
Yeah.
yeah, so we'll look at that in the next
But
few
if you don't mind, there are also some rich documents I can share with you guys
sessions.
to at least, give yourself the ability to look at it first before, like, if there is any arrangements on having to meet you like this and show you um,
Tutorial. Yeah,
maybe
okay.
like a deeper or customized. Often they want to take you through the beginner sessions.
Yes.
Then when you get yourself well acquainted, you want to like dive in. So
Dive in deeper. Okay.
maybe we can start with that, where you can get yourself acquainted on the surfaces. Then when we meet, we just dive in because like transport is very broad.
Okay. All right. Okay. So I think we would have to, the executives will look at it and connect with you, and then we'll arrange something like that. But then you can share your document you have with us so that we
Sure.
can start preparing for your lecture. Then we have
Yes.
another question from K. Dankwa. What is the model's advantage to the transportation system in Ghana, especially the Ayalolo system? Yes. So I think Dankwa was to look at how you can link what you did in your research with our transport system, which never came out, Ayalolo.
Yeah.
Yeah.
I have not worked with Ayolulu before, but I know like the model has gives you opportunity to do what we call driver behavior modeling. So you can sort of video the Ayolulu area.
Okay.
Maybe if you have an Ayolulu, you can video them, see, um, get some traffic parameters like their speed, their distances. You can look at the density they have, how they maneuver, and all those things. Then you can feed it into the system, and the system can give you data of how they will look like if So like you can create multiple scenarios on what is likely to happen to Ayololo in different scenarios. Then you can use that to plan your Ayololo. So maybe time schedules, and all those things. So public transport is a thing that you can use Sumo for, but I have not tried working with it. But now that you've mentioned it, maybe I can do something and look for grant.
Okay. Okay. So, somebody is asking for the link to our WhatsApp group. Yes, I'll share the link shortly so that you can join the Geo Infrastructure group, and then okay. Okay, another question is also asking. Another person is also asking if you can have access to the recorded version of this video. Yes, we'll make it available for you. Okay, so I think we've exhausted all the questions. We will still have some few minutes.
Okay.
If there are other questions, our host, please, can you unmute? Maybe some people would like to ask questions personally for the next maybe 10, 15 minutes before we go off. So if anybody wants to ask personal question, they can just they can raise up their hands, and then I'll call them to answer the question, to ask the question. Okay, so this presentation is also on YouTube. You can get access to it. Okay, we have a hand raised up. Please, can you mute yourself and ask your question?
Yeah, my name is Francis Anderfo. So I wanted to find out what is in Ghana at the moment, what is the geospatial application that the transporting sector is looking into? How are we using it in Ghana at the moment to solve our problem?
For the friends that I have in the sector, I know they are using it. Not necessarily Sumo, but there are other applications that are not like open source. I know about Vism, that I know they use Vism. But then they couple it with in situ ground measurement. So they will still go to ground, pick some data, then come and calibrate it with the software. So yeah, this is not new. It's out there. But yeah, when you talk about how far it has penetrated the system, that one I cannot tell. But I know some friends that are using it in the sector.
Okay.
Yeah. I hope, Francis, your question has been answered.
Yeah, like he said, maybe he's not in the direct industry sector. So, but the issue is that if I just felt that if we are using Inform or if we are doing simulations like this, some of the problems we have, we shouldn't have them. And that's why I'm wondering if we are using it at all, and is it really helping us? But like he said, he doesn't have the direct answer because he's coming more from the academia, so I get it.
Yeah, maybe.
So, have some few announcements. Our next CPD, Basics of GIS, which will be from the 30th to 31st of October. That is Wednesday and Thursday. So those who need the basics of GIS, please don't forget to tune in same time from 7, from 30th to 31st. And then after that, we're still going to have Dr. Entry2 coming back again for infrastructure mapping and data management. Yeah. That's going to be on 25th November. So please just note this on your calendar. And then our next CPD will be on 13th December. That is going to be from, it's going to be geospatial technologies in petroleum and application of GIS in petroleum exploration. Yeah. So these are going to happen just in some few weeks to come. We also have our second annual general conference meeting and conference. And the theme is going to be Geospatial Excellence for Digital Growth, Fostering Innovation and Collaboration to Unlock Ghana's Potential. Whoa, this team is fully loaded. I urge all of us to try and make it. It's going to be from Thursday, 28th November to 29th November, that's Friday. And the time is going to be 9 a.m. to 4 p.m. each day. And it's going to happen at the MT Adiko Conference Hall. That's Ghana Shippers Authority in Accra. Just Google the Ghana Shippers Authority and you will not miss the venue. So on this note, since we don't have any other question, I would like you to help me thank our most reverend Dr. Entry for taking us through. He has devoted his time, and me for one, I'm very grateful for what you are doing for the society. And we would like to see you again. That's in about 2 or 3 weeks' time, right?
Yeah.
Yeah, about 3 weeks' time. And before then, we would like to say a big thank you to you. Okay, so the link for the group, yes, I need to put the WhatsApp link for the group before I close it, otherwise you will not get any link. Can somebody help me with that? Just put the WhatsApp group in the, okay, yeah, somebody has done that for me. Thank you. Thank you. So we can all access the link and join the various WhatsApp groups now. Okay, so thank you all for coming, and it's been a lovely evening learning about our transportation infrastructure with geospatial as the backbone. Thank you all and have a good night. Bye.
Bye.
Bye.